Hello everybody, my name is Deep Pandey and I welcome all of you in this class from Study Bay Technologies. For your information, we are starting some matches for those people who are studying in engineering colleges, and in our today's session, we'll be covering one of the subjects from electronics engineering, and that is none other than signals and systems. Okay, so I welcome all of you to this first lecture. And in our today's lecture, we'll go ahead with some kind of understanding about what are the signals, what are the basic communications, what are the basic communication systems, what are the properties, and so on, like basic details or introductory session actually. So moving forward, first of all, what is signal? So I'm sure some of you might have heard about this term as well. So it's actually, if you want to define or you have a formal definition, it is nothing but just a function of one or more variables which conveys information on the nature of a physical phenomena, right? You can say that you are saying something or you are telling something to your friend, right? So you are sending some voice signal to your friend, right? It may be possible you are doing some communication with mobile phones. So obviously, again, that is just your voice signals which are getting converted to the electrical pulses or radio wave signals, or you can say some kind of a broadcast system that is actually used for transmitting the information from one system to another system or one person to another person or something like that. Similarly, like for medical background people or for doctors, the main requirement of signals of life that is related to heartbeat or pulse rate. These are the signals which are of utmost requirement for a particular physician or a particular doctor. So these are a type of basic type of signals like your voice signal, like your image signal, your heartbeat. Obviously, like we have different stock exchanges around the globe, and whatever the price fluctuation is going on, that depends on like how much hike or how much financial status of a particular country is going on. Based on that, there is some price fluctuations and all. So these are all can be comprised in form of a signal actually. Okay. So these signals can be represented in a form of a function, or in better words we can say it can be represented in the form of a mathematical function. Okay. Now why we are using this mathematical function? Because if we have to analyze a particular signal, we need some base, right? So if we need some base, the most logical objective over here is to convert a signal into some mathematical function. Then we will be able to understand the nature of that particular signal, like is it sinusoidal in nature, or is it linear in nature, or is it exponential in nature. So we will discuss all these details in some more in our another lectures as well. So by this way, the main objective of studying this particular subject is like how we can convert a particular signal into a mathematical function and how we can solve it on going forward. Okay. Now signals again can be defined in two parts. It may be your one-dimensional signal or your multi-dimensional signal. So one-dimensional signal is the one like whenever a function depends only on the single variable, just like your speech signal. Okay. But however, whenever it is dependent on two or more variables, just like your image signal, right? This can be called as your multidimensional signal. Okay. So this is a very brief idea about what a signal is. So moving forward, we can define something like that of system. Now what is this system actually? So if we can try to understand, first of all, in a system, a very important topic is something called as transmitter. This transmitter is basically a part of a system which is associated with the generation of a signal. That is a part from where the signal is supposed to be generated. Okay? And then we have a receiver. That is a part of a system which is associated with extraction of information from the signal. Now, how this information can be extracted? Obviously, like your system is being signal is being converted to a mathematical form, and then from here you can deploy some hardware, or you can program it accordingly, and once you receive a particular signal, you can use it as per your requirement. Okay. Again, the same thing is something like you can see in your landline telephones as well, right? What happens here? Your voice signals got converted to your electrical pulses, right? And then they get transmitted through wires or to some other medium as well. And then they get received through your receiver to a distant receiver actually. And there the conversion takes place from electrical pulses to your further voice sample, right? So this is the use of receiver and transmitter. And then there is a signal proposition. Okay, signal flow is there from transmitter to receiver. So I'm just giving this example just for your understanding purpose. However, the purpose of a system is completely depends on your application of interest. I have given you an example for kind of landline telephony. You can choose it for different set of environments which are available, like internet telephony. You can use it in your mobile communication. You can use in kind of Internet of Things as well. So these are the systems, but it completely depends on what kind of system you are dealing with. Just for an example, we have a communication system. That's basically a function of system is to transport the information content of a master signal over a communication channel and deliver it to the destination in a reliable fashion. Similarly, we have aircraft landing system, and the requirement is that it has to keep the aircraft over the extended center line of the runway. So you can understand very well that how important this signal and system subject is. Okay, so I have just given you some basic idea, some basic information about the signals and systems over there. So now let's proceed from here. We try to have some more information or idea about the system. So again, we can formally describe or define a system as an entity that manipulates one or more signals to accomplish a function, and thereby yielding a new set of signals. Okay, let's do one thing. Let me give you one more same kind of example. I mean, whatever I have given to you in our previous slide, the same kind of example I'm using it now. Your landline telephone system. Again, it's a system basically. So whenever you speak over there, what happens? Your voice signals are getting converted to the electrical pulses, right? So means one type of signal is getting updated to a new set of signals. That means your telephone receiver, telephone transmitter, you can say, it is getting some kind of signals from you, and it is yielding some different type of signal based on your requirement. Okay. So let's take one example here, like automatic speaker recognition system, under which it's a kind of a system. Like if you say something, it should be able to recollect who the user is. Right? You might have seen in some movies as well that it's a voice-based command and all. Or I'm sure these are very common system today. They're not very much complicated, but the thing is, like, I'm sure you might have seen it somewhere that whenever you speak something, your voice is used as a kind of a password. Okay. So let's say this is a user and it's saying something to the system, and the system is nothing but just your computer system over there, programmable device as well. And this is getting the information or identity of the speaker. That is the basic scenario which is explained over there. Right. And in a similar manner, we have something called as the aircraft landing system, and this signals, the purpose of the signal is the desired position of aircraft relative to the runway. Then here the system, which is nothing but just an aircraft, and output signal is a correction to the lateral position of plane. Okay, so on the slide I've just explained you the usage of the system over here. Now moving forward, I have a couple of examples related to the system. It includes, first of all, we have a kind of a communication system. So under this communication system, it has basic three elements over there. First one is a transmitter, a channel, and a receiver. Now over here, this communication system is again based on physical infrastructure, or it may be based on signal specification. So before I move ahead, let me give you some idea about the transmitter and channel receiver. So the transmitter is located at one point in space, and the receiver is located at some other point in space. That means these are separate from this transmitter as well. And the channel is actually the physical medium that connects the transmitter and receiver. And each of these three elements may be viewed as a system with associated signals of its own. Fine. Let's have some detailed idea about the transmitter. As the basic purpose of a transmitter is to convert the message signal, which is produced by a source of information, into a form suitable for transmission over the channel. The message signal would be speech signal, your television or video signal, or computer data. Okay. Similarly, we have channel. That the channel may be an optical fiber, coaxial cable, satellite channel, or mobile radio channel. Now, each channel may have its own area of application. Now, due to physical characteristics of a channel, whenever a signal travels through the same, it will get distorted. The channel output is also contaminated by the noise and interfering signals as well. And so the received signal is actually the corrupted version of transmitted signal. I hope, some of you might have studied the same kind of concept in the communication classes as well. So yes, in detail, we will cover this topic once we go for the communication system classes as well. Okay. So anyway, let's go ahead with the receiver part. So the objective of the receiver is to operate over the received signal. It has to reconstruct the same in recognizable form and then deliver it to the user destination. I hope this statement is very much self-explanatory. That means the output of a channel may be distorted or contaminated version of the input signal, and the objective of this receiver is to correct this distorted output and share the output to the user. Okay. Now let's discuss about these categories of the communication system. So these communication systems may be categorized based on their physical infrastructure and the specification of the signals that they transmit. Now, the physical infrastructure pertains to the type of channel used and hardware design of the transmitting and receiving equipment. And the signal specification signifies the nature and type of the transmitted signal. Now, first of all, based on physical infrastructure, let's try to understand how and we can classify this physical infrastructure setup actually. So based on this physical infrastructure, there are two different types of communication system. First one is a line communication system, and the second one is your radio communication system. Okay. So you can see here that the example that I have mentioned over there is like in case of line communication system, there is a physical link called hardware channel between the transmitter and receiver over here. However, in case of radio communication system, there is no such link, and natural resources such as space, water are used as softwise channels. So a particular communication system can be one of these two types. Just for an example, we can say that the radio broadcast is purely into radio communication system and cannot be categorized as line communication system. On the other hand, the landline telephony is purely a line communication system and cannot be typed as radio communication system. Okay. Now consider over here a TV system in which a user can only receive the signal and view the available channels. Here a TV receiver cannot transmit the signals. However, in telephony, we can transmit as well as receive the signal. So TV transmission is one-way transmission, and that's why it's called as simplex. While telephony is a two-way communication or two-way transmission, that's why it is called as duplex. In our given example, you can understand over here, like we have two different computer systems that can communicate with each other. I'm sure all of you have done some online chatting. Most of you have, your Facebook profiles and all, right? By which you can do some kind of chatting with your friends and all. So what is actually going on? You're just communicating with one of the computer. One computer is communicating with another computer, something like that, right? So this is something called as your duplex system. Okay. There is one more example related to the same. Like we have, client and server kind of module. Those who are those people who are very much interested in computer science or information technology and so on. You might have heard of we have a server, we have a client. You might have heard of all these terms, right? So if the server is working fine, then you will be able to get the data. You can communicate, with the concerned server, and you can extract the information. Very common example, that is your railway booking website, right? So what is actually going on over there? You are just communicating from one computer to another computer. It is in a both bi-direction actually, and that is called as your duplex way of communication. So the one way or two way the transmission features of a communication system depends on the design of the equipment used on the two sides of communication system and therefore included in the physical structure specifications of the system. Okay. So as a rule of a communication system, it can be either simplex or duplex, but not both. A system may be simplex or it may be duplex, but cannot be both actually. So here if you can talk about this baseband on the physical structure of a communication system, you can define two groups and only one specification from each group is required to decide the type of communication system. And these are group number one, that is line or radio communication, or simplex or duplex communication. Okay. So just for an example, like your TV communication is a radio communication and simplex communication. Similarly, landline telephony is line and duplex communication. Similarly, it depends on your mobile communication is your radio and duplex. Okay. So, wait, let's go ahead. Now, in terms of signal specification. We have one more, another part of this difference. We have signal specification based on previously we have studied about the physical infrastructure, how we can define a signal, and now we are going to study about how we can define it based on the signal specification. So the signal specification used to decide the type of communication system that include nature of the baseband or information signal or nature of the transmitted signal. Okay. Now based on the nature of the baseband signal, these are of two types. Two types of communication systems are there. First one is your analog communication system. You know very well it's about the TV transmission. And then we have a digital communication system, that is high density TVs of transmission. Okay. Then based on the nature of transmitted signals, the baseband signal can either be transmitted as it is without modulation or through the carrier signal with modulation. Again, the modulation we might have studied in communication system as well, wherein we superimpose a particular signal with a carrier wave, right? So we will discuss about that as well in our further classes. So now these type of communication systems can be categorized as a baseband communication system or carrier communication system. So baseband communication system is under the landline telephony and carrier communication system is your TV transmission. That means in baseband communication system, like we are transmitting the signal as it is, and in carrier communication system, we are doing some kind of modulation. Okay. So therefore, there are four types of communication systems that can be categorized based on the signal specifications, and these are analog communication system, digital communication system, baseband communication system, and carrier communication system. Okay? And of these four, at least two types are required to specify a particular communication system. And these two groups formed consisting of the two types such that at least one of the types form each group. And that is necessarily required to specify a communication system that is either analog or digital communication system or baseband and carrier communication system. So a particular communication system is either an analog communication system or digital communication system at a time. Similar rule holds for the baseband and carrier communication system as well. So for an example, the TV transmission is analog. HDTV is a digital. Landline telephony is a baseband. TV transmission is again a kind of your carrier that requires a kind of a modulation system. So therefore, to completely describe a particular communication system, there are four of the 8 type of communication systems are required. So if any one type is missing, then the description of communication system is not said to be completed. So in order to make things simple, loud and clear, there are 4 groups containing these 8 types are formed, such that only one choice is possible from each group, and the 4 choices together describe a communication system. First group include line or radio communication system. Group number 2, that is simplex or duplex communication system. Group number 3 includes analog and digital communication system. Group number 4, it includes baseband or carrier communication system. Okay. Here, the TV transmission, if we talk about, or we can try to combine whatever we have studied so far, the TV transmission is a radio, simplex, analog, carrier communication system. Fine. Similarly, the landline telephony is a line, it's a duplex, it's analog, and baseband communication system. Clear? So these are a few details related to the communication system. Now let's have some idea about the control system. Control system is again, it's a very good subject that we might have to study in our engineering course as well. We'll have a separate class for that as also in our next future or upcoming classes as well. So let's proceed from here. In a control system, that is here the application of signals and system, as you know, that these are associated to the control system as well in our industrial society, or like just you can call it as in part of robots. It can be used in aircraft, autopilots. It can be used in automobile engines as well. The object to be controlled is commonly referred to as plant. And in this context, if we are talking about aircraft autopilot, in this context, the aircraft is a plant. Now, the important question is why control systems are used. The reason is their response and robustness. So, a plant is set to produce a satisfactory response if its output follows or tracks a specified input. And the process of holding the plant output close to the reference input is called as regulation. Okay. Similarly, about robustness. Here, a control system is said to be robust if it exhibits good regulation despite the presence of external disturbances. And in the face of changes in the plant parameter due to varying environmental conditions. So in order to attain these desirable properties, we need to have a feedback mechanism or a closed loop control system as well. Okay. Similarly, we have a system kind of remote sensing. Remote sensing is again, this is defined as the process of acquiring information about an object of interest without being in physical contact with the same. The acquisition of information is accomplished by detecting and measuring the changes that the object imposes on the surrounding field. Okay? So the acquisition can be done in two different ways, either your sensors or your remote sensor or setup. It may be working in a passive manner or it may be working in an active manner. Okay. If we are talking about the remote sensing, you might have seen remote control, TV remote controls as well. And there are the sensors actually, like your PIR sensor, that is a passive infrared ray sensor, which senses the motion, right? We have infrared sensors. We have laser sensors, right? We have light sensors, sound sensors. A lot of sensors are available over there in the market, right? And there is a very new and very emerging, a very good field here, which is using these sensors along with the, your decision control environment that comes under the, very good technology, that is your Internet of Things, right? So later on in some class we will discuss that in very much detail as well. So right, let's go back to the passive and active sensing object. So passive manner means like listening to the signal that is naturally emitted by the object and processing the same. I have taken one example for PIR sensors, right? That is passive infrared ray sensor. So we all know very well that our body heat is there, and whatever we are doing actually, our body generates some heat, right? So this PIR sensor actually senses the heat that is generated by your body actually, and based on that it detects the motion of a person. Fine. Similarly, we have active manners or active mode of acquisition, that is by purposely eliminating the object with a well-defined signal and processing the echo from that particular object. A very simple and very straightforward example for the same is your radar signals, right? So it's like you might have heard of there are two different types of radar. One is your primary radar, one is your secondary radar. The objective of primary radar is to just share the just emit the signals, and it has to sense the echo of a flying object, and based on that it can define how much height is that and how much what is the velocity of that particular flying object and so on, right? So this is nothing but just a kind of active mode of your remote sensing over there. Fine. Now let's discuss about analog and digital signal processing here. Okay. So signal processing operations involved in building communication system, control system, etc. can be implemented in two ways. First one is the analog or continuous time approach, or digital or discrete time approach. Okay. So analog signal processing, it requires elements that involve analog circuit elements such as your resistors, capacitors, inductors, diodes, and so on. These are all just your analog circuit elements. However, your digital signal processing relies on three basic digital computer elements. These are your adders, multipliers, and your storage structure. Okay. Now, analog approach is assured of real-time operation, right? Now, what is this real-time operation? A real-time operation means like at the moment you receive some input, you should generate the output. Okay. Let's take some example for this about the real-time setup actually. Like I was talking about a PIR sensor, or in other words, let's say you have alarm system which is installed, or security alarm system actually. So what happens if an intruder enters to your home, right? The body heat of an intruder will be sensed by the PIR sensor, and it will confirm that okay, somebody has just moved in to this house particular or from this particular location, and it will start ringing the alarm, right? Immediately at the moment the body heat is detected, the concerned signal will be given to the alarm system. That is your real-time environment. Okay. Then in case of digital or discrete time approach, there is no such real-time environment, but yes, it has an advantages of flexibility and repeatability. Now what is this flexibility here? This flexibility is something called as, like in some hardware, or you can same kind of hardware, whatever you have used can be used to implement different versions of signal processing operation of interest, merely by making changes to the software read into the machine. And on the other hand, the system has to be redesigned every time the signal processing specifications are changed in case of analog machines. You know very well about your computer system, right guys? And I'm sure some of you might have upgraded your computer system from one Windows version to another Windows version and so on, right? Some of you are using dual kind of operating systems as well. How it is going, how it's going on actually? The thing is like you just upgrade your system, or you just add a new delete some kind of programs whatever which are running in your computer system, right? Similarly about the repeatability. The digitally implemented operations can be repeated over and over again. However, in case of analog systems, the variations in factors like voltage, room temperature, etc., can result in deviation from the result. Very, very common example. I have used the same setup like for intrusion detection or theft detection or security alarm system. Let's take an example of something like, let's say your voltage is quite low, right? those who have done some kind of practicals religiously in your practical labs, actually, you know very well that every IC, every sensor needs some power, right? That is a VCC voltage. Am I right? This VCC voltage is very much required for the operation of your device or electronic device. Let's say this VCC voltage is very low or it's down now. Your sensor won't work here, right? So these are actually, the results in a deviation. Or in some other way, like let's say the operating temperature is very high, right? The sensor won't work actually, fine. But in case of digital systems, if you have a digital system, they are completely out of, these kind of issues, right? It can be repeated over and over again. And the choice of analog or digital system completely depends upon the application of your interest, the resources available, and the cost involved in building the application. Okay. So, however, in practical environment, the vast majority of systems are mixed in nature. Okay. So, these are details about the signal processing. Now, something about basic types of signals. Okay. So, we can have analog or continuous time signals, or we may have digital or discrete type of signals. Okay. So, let's go ahead. We can define analog signal with symbol x and with a function as t. You can see that this is a basic graph for an analog signal, right? So the signals can be represented in different ways, and in all cases, the information contained in a signal in a pattern of variation of some form, right? This continuous time signal, like it may be your human speech and so on, that's what we have already discussed. Similarly, a discrete time or digital signal can be represented as x within a square bracket m. And this can be represented in the form of a graph like this way. Okay. Moving forward. Again, there are one more class for another class for the signals. They may be even signal or they may be odd signals. So if the signal is identical to its time reversed counterpart, in that case, we can call it as an even signal. Okay, and this is always symmetric to its your y-axis with respect to the y-axis. Fine. So similarly, these even signals and odd signal even signals. Let's talk about the even signal first of all. These even signals again, can be represented as continuous time and discrete time signals. Okay, and yes, in case of this continuous time signals, these are again the values of independent variables, right? The discrete time signals is defined only for integer values of the independent variable. Remember that. Similarly, the discrete time signals arise from the sampling of continuous time signals. Just for an example, you can have a digital processors over here, right? Now, similarly, we have kind of odd signals as well. You can see this example of an even signal first of all. Then we have an odd signal if the signal is not identical to its time reversed counterpart. That is x of minus t is equal to minus of xt, or x of minus n is equal to minus of xn. So these odd signals, remember that these are symmetric to the with respect to the origin. Okay. If you can take an example of an even signal and odd signal, you can see here it's a square graph is an even signal, and the cube graph or linear graph is basically your odd signal. Right? Now moving forward, something about periodic signals. Signal is said to be periodic if x of t is equal to x of small t plus capital T, where capital T can be represented as period. And the smallest value of the capital T is called as fundamental period of xt. And the frequency of a particular signal, which is measured in hertz or cycles per second, is the reverse of your fundamental period. And the angular frequency, that is represented by 2 pi oblique t, 2 pi by t. So if this relation, that is xt is equal to xt plus t, capital T, is true, then the signal is said to be periodic signal, or else it is called as your aperiodic signal. Okay. It can be said something, you can see in this below axis bars actually, like we have a period like t, 2t and 3t and so on. So the signal is something like this way. You can see here the signal is being repeated after every time period, that is 0 to t, it is now repeating once again. Again after 2t, it is again repeating itself. Again after 3t, it's further repeating itself. It's something like this. Okay. So this can be set to a periodic signal. Now energy and power signals. Again, this is a very important point over here. Let's say I have a resistance R over there, and I am applying a voltage, which is a function of time, and some current is flowing through it to this particular resistance. So how we can specify the power? Power is specified as V square by R, or you can call it as I square R, right? This is the power dissipated over there. So we can, just check it out as a part of some s square t. We can take it as a function. Now energy of this is something like integral from 0 to t, that is x square, that is the square of your concerned function over there, that is power. You mean you are integrating the power to get the particular energy in that particular domain. Now average power is called as your energy divided by the time duration, that is 1 by RT of 0 integral 0 to t s square dt. And similar way, if you limit it up to infinity, time up to infinity, that is called as your signal energy. Okay, that is 1 upon t integral minus t by 2 to t by 2, and then the square of the concerned function. Okay. So it will be good if you can remember these formulas. We will be using these formulas in our under classes as well. Moving forward, in case of energy and power signals, we have three different classes. Class number 1, that is signal with finite total energy. So let's see. This is kind of a signal that will the signal which is having finite total energy. This is the graph of the signal, right? That is between time between 0 to 1, that will be a unit signal. Okay, that kind of signal will have finite total energy. The next class is a signal with finite average power. Okay, that is again unique signal over there. Alright, it's a kind of a digital setup as well, like let's say this is 4 volt or whatever it is. So you can signal with finite average power, not going down to 0. Remember that. Okay, this value can be anything from 0, 1, 2, 5, 6, 7, 8, whatever it is. Similarly, the signal with neither finite total energy nor finite average power. Okay, and that is your linear signal. Okay, the linear signal is the one which is constantly increasing, neither it has finite total energy nor it has finite or average power. Fine. Then it's up to so far. In our next lecture, We'll study about operations on signals. We'll study about basic elementary signals. Basic elementary signals, which include your kind of signals which are related to exponential signals, sinusoidal signals, step function, impulse signals, ramp functions, and so on. Right. And we'll also see like how they can be operated actually, and we'll understand the interconnection of systems. I hope you enjoyed the lecture. Please go through it. If you have any queries, any questions, please write it on the comment box. Okay. Have a nice time ahead and take a very good care of yourself. Bye-bye.